In this video, I'd like to show you a little bit about how to get started with self-driving sandbox. First thing you want to do is go to the GitHub page here and clone the source to your machine. You can do that using Git, or if you like, you can also download a zip. If you do decide to use Git, if you hit this button, it will copy that to your clipboard, and then you can go to somewhere on your machine. I like to use a projects directory, and if you do git clone, and then you can paste that URL, that will pull down all the source for you. And when you do it that way, that allows you to get updates in the future, as opposed to downloading. You only get it once, and then you have to download it again if you want to get an update. Once you do that, you'll have this SDSandbox directory. And in the future, after you pull down, and if you want to get updates, you can do a git pull, and if there's any changes, those will come down. And if you'd like, you can work on the repository yourself locally, and you can merge those changes in as they come down. But I'm not going to cover that. So that's the basics of getting the source down on your machine. Okay, once you do that, you're going to want to install all the dependencies. The dependencies are listed at the bottom here. You want to have Python 2.7, and I'm pretty sure that in order for TensorFlow to work correctly, it's going to need to be 64-bit on almost any platform. I've tested this on Ubuntu and Mac OS X and Windows, and it seems to work on all of them. TensorFlow, I'm not sure if it has to be this version. I think you can install the latest, and you'll probably be fine. And Keras, that should be sufficient. You know, I'm not actually sure if you need CV2. You might be able to get away without it. If you'd like to skip that, you can come back to it. I should double check that. But I know for sure you need H5, and you need Pillow, and you need to install Unity. So for these are Python modules. So for all of these guys, you can do a pip install, and usually you want to do that as sudo. And you can try TensorFlow, and then if you run that, it'll get TensorFlow, and then Keras you can install that way. H5 might be H5 Pi, and Pillow you can install just as it says, all lower Pillow, and that will get you all those dependencies. Next, you would want to get Unity. I'm using 5.5. If you're at a higher release, that's probably fine. If you are new to Unity, let me see, I'll open the web page somewhere. Oh, here we go. Yeah, on Unity, you just go to Unity 3D, download, and then you can choose your download. You want to use the free version is completely fine for what we're doing. And then you can download this installer, or you run the installer, and it will ask you which platforms you're going to target. If you just target the desktop for whatever operating system you're running on, that should be just fine. Once you download Unity and you launch it, you will get a screen. This is actually running Unity right now, but you'll get a screen that says, that looks here, let me quit it real fast. And I'll start it again. First, you have to create a Unity account and sign in. And once you sign in, you'll see a projects here. And then there'll be an open. Then this will probably be empty. And you want to click on open. And can I move this dialog? I can't. That's pretty annoying. And then you want to browse to wherever you have your wherever you downloaded the source. So for me, it's under projects, SDSim or SDSandbox, and you want to select this SDSim folder, and then you want to click open. I already have it because I've loaded it before. So once you do that, it'll show up as an option. And I think when you initially load Unity, it's going to come in empty. It's not actually going to show this. You'll see two things on the side and an empty scene. And so what you have to do is, it might even show you something like this. You have to click on this Projects tab and then look down here in the Assets folder and click on Scenes. And there's two scenes here. The one you want is main. And if you double click on that, it may do a little asset generation. It may take a little time, but once it does that, it should end up with something like this. You should have these at the highest level, and you may or may not have a view like this depending on if 2D is selected or 3D is selected. So let me show you a little bit around the Unity aspect. Well, first let's do the quick kind of getting started. So the way you launch the scene, once you've loaded, this is the main scene. Once you've loaded that scene, you push this button up here with the triangle to run it. Once you run it, there are three options here. The first option says use PID steering. That's using kind of a robotic style. It figures out the deviation from a path, and then there's an algorithm that proportionally steers it on the path. So this is not using neural nets. This is actually using, well, let's talk a little bit about this world. So this world starts out as a random path that gets generated. And then from that random path, I generate a road mesh. And so this PID steering, if I click that, you can see that it's going to start driving. And as it drives, it will kind of oscillate here, and you'll see up here in the steering, the PID, you'll be able to see this is the steering angle that it's using. Now if we start it again, so I clicked that button to stop it, and then I clicked it again to start it again. We can try the neural net steering. And the neural net steering is moving, but it's not steering at all. That's because you have to, it's actually, from within Unity, it's connecting to where it's looking for, I haven't run it yet, a Python process that's hosting the neural net. So let's get that. What you want to do is you want to start that neural net first. So let's go to Sandbox and change to source. and type Python predict server. So predict server is the Python script to run a network listener that's also hosts the neural net. It's going to load the model highway that is pre-generated for you. It's in the output steering model directory, and once you hit enter there, it's going to show you that it started TensorFlow and that it is now listening for connections. So let's go back to Unity now that it's running and listening for connections. Now if we hit use neural net steering, you can see that it is now steering. And if you switch to the terminal, you can see that it got a new client. So that's, and if you look in the steering up here, you can see that it says NN, that's your neural net. And here's the steering value that's coming from the neural net. And now it's self-driving. So, well, actually, to be perfectly accurate, it's self-steering. The throttle input is coming artificially from something else. I can show you where that is later. For now, it's just a constant throttle, and the steering information, it's taking an image from the camera sensor, and it's sending it to that Python process that's listening, and that Python process takes the image, submits it to the neural net, comes up with a steering value, and sends it back into Unity, and then Unity uses it to turn the steering wheel. If you come over here and look at controllers, and then click on network steering, you can see this is the network process that's connecting to our local host, and you can see it changing state here as it's feeding images to the network process and getting them back again. Okay, so that kind of shows you the very basics of running Unity, connecting to the neural net server, and seeing a pre-trained network. Next, I'm going to show you how to train your own. Now, to do this, the first step is you want to create your training data. To create training data, the first thing you want to do is make sure that you have your logs directory created. So let's go to terminal. Let's stop that server. And let's look at our SDSim directory. That's where the Unity is. And we need to make a logs directory. Actually, it's called log. You want to make a log directory there. That's going to contain the image and steering data from Unity. So I just created it. So of course that's going to be empty. And you can see it's empty. So let's generate some data and then see what that looks like. So come back to Unity, hit this plus to start. We've got a new randomly generated road, and now we're going to hit generate training. When we're generate training data, the PID is taking over. You can see the steering data that the PID is generating. And if you like, you can click over here on logger, and you can see what frame the logger is on right now. It's 800, 900. It's real tiny right here. And it's set to cap out at 5,000. But you can let that run as long as you like. When you have a nice long run, then you want to hit the start button again to stop. And now let's see what we created. So go back to terminal and let's list that directory now. And now we have a bunch of images and we have a text file. That text file has the control data, it has the steering data and the velocity data, the throttle data. Right now we're not using the throttle data, but you could, and if you want, you can generate other data as well. From that data, we need to kind of bundle it up. Right now, it's these images. You could train against this data, but we're using the Comma AI framework, and that's set up to work with the H5 format, which is kind of like a database file. It takes all these images and all the control and puts it in a flat file that makes it really fast to access. So the way you create those files to get ready for training is with the prepare data script. And that has a convenience flag, which is clean, which will, after the data is prepared, clean out all these images and log files. And so if you don't want to, if you omit the clean, it will leave these images here for you if you have some other use for them. But as I don't, I'm just going to go ahead and do that. So it reads in the steering records first, and then it reads in the images. And because I specified clean, my log directory is now clean. And what it's done is it's now put them in the datasets folder. So there's two folders in there. There's a camera and a log. So if you look in the dataset camera, you'll see that it, by default, it makes a training set with the prefix of train and then the current date and time, and it's a .h5. And if you look in the log directory, you'll see it's the same name, and that's going to be the steering data and the throttle data. And that's what's used to train. So now that we have, so you want to run that a number of times to create a lot of training data. And then after, on your very last run, you might want to create, well, you definitely want to create at least one. You can create multiple if you like, validation sets. To create a validation set, it's just like the training set, except when you prepare the data, you can do -- validation, and that will create a set that has the prefix VAL. And that just helps the training automatically know how to partition the training and validation when it's setting things up. So now we're ready to train. When you train, let's see, you can use the train.py convenience script. If you're familiar with Comma AI, that it fires up fires up a training server and a validation server, and then in two separate processes, and then it will run your training in a third process. This is just a convenience script that launches them all as subprocesses within one script. So whatever you're comfortable with, you can, if you're comfortable with the Comma AI, it gives you a lot more control. There's a lot more options. So you're welcome, but initially let's just try this. So Python train py, and then you have to pick a name for your model. It can be anything. If you're doing a lot of experimentation, we can just use whatever we want, but for now we'll just call him newbie. So that's going to start up. It's going to load. You can see that it loaded 3. So it's the output is coming from 3 different processes in the same terminal, so they kind of get mixed together. But you'll see here that training is started, and it's got an ETA of 96 seconds. So we'll just fast forward to the end of that. Actually, I'm just gonna cut it off. I'm gonna do Control C because I've already done this. So once your training is finished, and it can take quite a while. I'm running on a machine without a GPU, and it takes like 12 or 14 hours, sometimes longer, to complete the training. But it's worthwhile to let it finish. The results are definitely much better when you do. So let's take a look at what that created. Let's see, that's outputs. So that created a newbie.json and a newbie.keras. The JSON file specifies the topology of your network, and the .keras file are the weights. So those will be loaded back into your TensorFlow, and you can use that in your server to serve up steering data. And the way you do that is Python predict server py with whatever your model name is, like that. And then you can come back and hit start and use neural net training. And now you can see it's connected, it has a new client, and it is sending your steering data back here. Okay, that's about it. If you have any questions, go ahead and leave them in the comments, and I'll see if I can't help you.